1-4 Properties of Real Numbers. In our previous lesson, we learned how to classify real numbers between rational and irrational. Today we're going to review properties we have learned before and apply them to simplifying expressions. Alright, so we have 5 properties that our book covers in this lesson. The first two I think you've heard before. Commutative property. Commutative property has to do with order. In other words, if I have two numbers being added together, a plus b, it's the same thing if I flip the order. B plus a is the same thing. 4 plus 7 would equal 7 plus 4. The commutative property of multiplication is the same. Order doesn't matter. A times b is the same thing as b times a. So commutative has to do with order. Associative property has to do in the way that we group our numbers. Grouping doesn't matter for addition or multiplication either. The associative property of addition says that if I have a and b grouped and they're added together and I add c, it's the same thing as grouping them a plus b plus c. So I changed which two numbers were in the grouping symbols, but because we're adding, we'll get the same answer. Same thing for multiplying. A times b in a grouping symbol times c is the same thing as a on the outside times b times c in the inside. That is the associative property. Grouping changes. Identity property, there's also one for addition and multiplication. Identity property, think keep your identity. Meaning if I have a number a and I add 0, I still am left with a. My identity did not change. So the addition property of identity, when you add 0, you keep your identity. For multiplication, if you multiply by 1, you keep your identity. So 4 plus 0 is still 4. 8 times 1 is still 8. That's the identity property of addition and multiplication. There are two other properties. One is called the zero property of multiplication, or multiplication property of 0, however you want to say it. That's if you start with a number and you multiply by 0, you'll always get 0. So negative 3 times 0, 0. That's the zero property. The multiplication property of negative 1 is whenever you take a number and you multiply by negative 1, your answer will be the opposite sign of the number you started with. So a is positive. If I multiply it by negative 1, I get negative a. If I was multiplying negative 1 by a negative a, the sign switches and I now have a positive a. So multiplying by a negative 1 changes the sign of the number you start with. Okay, so those are the properties we're talking about in this lesson. Again, commutative changes the order. Associative changes the grouping. Identity properties keep their identity by either adding 0 or multiplying by 1. Zero property, we're left with 0. And property of negative 1, we're left with the opposite sign of what we started with. Okay, so let's use these properties to define these statements. 42 times 0 equals 0. Well, I know anything times 0 is 0. So that is the zero property of multiplication. Zero property. Letter B. Y plus 2.5 plus 28 equals y plus 2.5 plus 28. Sounds the same, but notice that in the first one, y and 2.5 are grouped, and in the second one, 2.5 and 28 are grouped. Because the grouping changed, this is the associative property of addition. It's really important that you say, is it of addition or multiplication? And I know it's addition because we're adding. Example C, 10x plus 0 is 10x. My identity didn't change, so that must be an identity property of addition. Again, don't forget that of. All right, two more. 4x times 1 is 4x. Another identity. This time it's identity of multiplication. How about B? X plus square root of y plus z equals x plus z plus square root of y. You might think it's associative because you see grouping symbols. However, this problem is trying to trick you. If you notice in the grouping symbols here, we have square root of y and z. In the grouping symbols here, we have square root of y and z. The groupings did not change. X is still on the outside. What changed is the order within the grouping. Square root of y and z, z square root of y. This is a commutative property of addition because we only changed the order in which we were adding. So it's really important to look closely. All right, we can use these properties to solve mental math calculations. If I went to a movie and my ticket cost $7.75, my drink cost $2.40, and my popcorn was $1.25, what's the total cost for all three? I can find an easy way to add by starting with two numbers that go well together. $7.75 and $1.25 add nicely. So I want to add those first, then add my $2.40 to get my total. So when you're doing mental math, just try to switch the order of the numbers that you are dealing with to make the math easier for yourself. All right, our third example of this lesson is simplifying expressions while we justify. In 8th grade, you need to know how to explain yourself for all the steps you do. That's what we're going to practice now. All right, in my first expression, I have 5 times 3n. I know right away this is 15n, but I'm going to show using properties how I get this answer. So I'm going to rewrite my problem, 5 times 3n. This was given to me. Now, I know I need to multiply the 5 and the 3, but technically they're not grouped together. So I'm going to regroup the 5 and the 3 together and multiply the n on the outside. I can do this because of the associative property of multiplication. It doesn't matter how I group. Now I can do my math. 5 times 3 is 15 times n, and my reasoning for that is I just simplified. So that's how you justify that problem. Here's another one. 4 plus 7b plus 8. Notice we're adding the whole time. I would like to add the 8 and the 4 together. However, they're not next to each other. When we're justifying, we have to be very thorough. So this step was given to me. If I want my 4 and my 8 next to each other, what if I switch the order? So I have 7b plus 4 plus 8. I didn't change any groupings, but I changed the order, commutative property of addition. I changed the order of this parentheses. Now I can regroup my 4 and my 8 so I can add those together. So the 7b is on the outside. That is thanks to the associative property of addition. I changed the grouping. Finally, I'm just going to add within the parentheses. 8 plus 4 is 12. Add my 7b. That is my final answer because these are unlike terms. 7b plus 12 is my final answer. This is how I justified that answer. Here's our third and final example. This one can be a little bit more confusing. Just follow along. So I have 6xy divided by y. If I jump ahead, my y's will probably cancel out, and my answer should be 6x. Let's justify and see if we get the same answer. All right, so here's the first step. Here's where we started. Notice that they split up the 6x and the y with a time sign, and they put a 1 times y. That's because since these y's match up, they wanted them to be up vertical from each other, so we needed something to be under the 6x. Well, 1 times y is the same thing as y. I know that because of the identity property of multiplication. So I just rewrote the denominator y as 1 times y. All right, now all I did was I split these two into their own fraction. I can do that with the rule of fractions. A over B times C over D equals AC over BD, meaning 6xy is the same thing as 6x times y. 1y is the same thing as 1 times y. So I just rewrote those as separate fractions. You'll see why in a second. All right, now I have 6x times 1. This is because x divided by 1 right here just equals x. So I have my 6x. Y divided by y equals 1. So that's why I wrote the 1. So those are two rules as well. Now, 6x times 1 is the same thing as 6x. That is because of the identity property of multiplication again. And that's our final answer. All right, I'm going to move on to our final problem from this lesson. Two vocab words, deductive reasoning and counterexample. Deductive reasoning is when you process something logically because you have been given facts to make a conclusion. And when you prove something isn't true, you use a counterexample to prove something to be false. Let me show you an example. Example A. For all real numbers A and B, A times B equals B plus A. I'm going to use deductive reasoning, meaning facts that I already know, to say that this statement is not true. This is false. I know this because if I said A was 5 and B was 3, 5 times 3 is 15, and that doesn't equal 5 plus 3. Okay? So I just gave a counter example. False, and then give your counter example. Example B, for all real numbers A, B, and C, A plus B plus C equals B plus A plus C. Now that looks right to me. I'm going to say that's correct. I don't have to say anything other than true, but if I want to prove myself, this is true because of the commutative property of addition. So this is true. Commutative property of addition tells me that it is true. And associative changes the grouping symbols as well. Okay? So if it's false, you want to give that counter example. Great, that brings us to the end of our lesson. Please complete the lesson check and bring your notes and answers to class.